Alright, today we're going to talk about section 8.2, which is talking about lines, slope, average rate of change, which are all related to slope. So we're going to talk about linear equations in two variables and what exactly that means. We're going to talk about what are x-intercepts and y-intercepts and how to find those. We're going to talk about, we're going to talk about slope. We're going to talk about slopes of parallel and perpendicular lines and how they're different. And we're going to talk about average rate of change and how to use that in a real life situation. So the first thing we're going to look at is what we refer to as a linear equation in two variables. And these are equations that are in the form ax plus by equals c. This is called standard form. A and b also cannot be fractions or decimals. So in this situation, a and b are integers. When we're in standard form, just to keep that in mind. And they're always going to represent lines because the x and the y variables are not squared or cubed or anything like that. So this is referred to as a linear equation in two variables. So we're able to find the ordered pairs of any linear equation, and technically there's an infinite number of solutions. I could pick any x values I want, and I should be able to figure out some sort of y value since they are linear. Alright, so here's an example. Find the answers for this problem. So remember, I've got four sets of ordered pairs here. This is x, and I'm looking for y. I'm looking for x, this is y. I'm looking for x, this is y. This is x, and I'm looking for y. So on these problems, what we're going to do is we're going to take the equation 2x plus y equals 4, and we're going to replace whatever piece we know. So on the first problem, I know x, but I don't know y. So I'm going to replace x with 0 and leave y alone. I'm going to solve this problem, so this is 0 plus y equals 4, so y is equal to 4. So then on the second problem, I'm going to replace y with 0, but I'm going to leave x alone. So I have 2x plus y equals 4. 2x plus 0 equals 4. And again, solve for x. So x equals 2. On the third problem, I'm going to substitute y for 2, or 2 for y. So I end up with 2x plus 2 equals 4. Solve for x. Subtract that 2 from both sides. So 2x equals 2. So x equals 1. So this would be the point 1, 2. And then the last one, I'm going to replace negative 1 for x. So I get 2 times negative 1 plus y equals 4. So this is negative 2 plus y equals 4. Add 2 to both sides. So y equals 6. So now, if I were to take those points and graph them, over 0, up 4, there's my first point. Over 2, up 0, there's my second point. Over 1, up 2, there's that third point. And negative 1, positive 6, there's my last point. So you'll notice that those 4 points form a line. So it's again called a linear equation. And all I did was substitute. I could have picked any values that I wanted for x, and I could have figured out y, or I could have done the same thing for y and figured out the x values. So this is just something to keep in mind. So when we're looking for what we call the intercepts, we're looking for the places where the line crosses the x-axis and the y-axis. So if we go back and look at that example that we just did, this line crosses the y-axis at the point 0, 4, and it crosses the x-axis at the point 2, 0. So this is my y-intercept, and this point down here is my x-intercept. It's where the line intercepts the x-axis or where the line intercepts the y-axis. So if you'll notice what we're saying here is that to find the x-intercept, we're going to set y equal to 0 and solve for x. And to solve the y-intercept, we're going to set x equal to 0. So again, let's go back a second and look at that example. The y-intercept is 0, 4. We set x equal to 0. The x-intercept was 2, 0. We set y equal to 0. If we know what the x-intercept and the y-intercept is, typically we can graph the line without having to graph a whole lot of extra points. So again, we're going to go through this to find the x-intercept and y-intercept. So x-intercept, we're going to set y equal to 0. So it's the opposite of what you're doing. So x-intercept, we set y equal to 0, solve for x. So x equals 2/4, which is 1/2. So it's the point 1/2, comma, 0. To find the y-intercept, we set x equal to 0. So we have 4 times 0 minus y equals 2. So we have negative y equals 2. So y equals negative 2. So my y-intercept is the point 0, negative 2. So knowing those two numbers, I can graph my line. 0, negative 2 means go 0 on the x and down 2 on the y. There's my y-intercept. X-intercept is 1/2, 0, so we're going to estimate where 1/2 is. And then connect those 2 points together, and there's our line. Another way of looking at this problem is what we refer to as maybe a cover-up method. And what you can do is, if you're trying to find the y-intercept, you can cover up the x. You can cover up the x and pretend it's not there and solve for y. And to find the x-intercept, we're going to cover up the y, pretend it's not there, and solve for x. So those are another way of thinking about it. It's called a cover-up method. You might have seen that before. All right, so how do we graph when we just have an x or a y? We don't have both. So what we're going to look at here is think about our chart or think about our table of values. So what I'm telling you to do is pick numbers for x and you're going to find y. Well, the catch is we know y is 3. So no matter what you pick for x, y is 3. So no matter what you pick for x, y is 3. So pick random values for x. So I could pick 0. It's always a good one to start with. Negative 2 would be another one. And I'm just randomly picking these numbers, and we'll say 3. So these are my x values. These are my y values. If I graph those on a graph, 0, 3 would be over 0, up 3. Negative 2, 3 would be negative 2, up 3. And positive 3, 0 would be positive 3, and up 3. And you'll notice that if I connect these 3 points together at the top of my graph, I end up with a horizontal line. So the graph of a problem that starts with y equals 3, is always a horizontal line. So if I had the equation y equals negative 2, my answer would be this line down here at the equation y equals negative 2. If I said y equals 2, then my line would be right here at y equals 2. So this is the graph of y equals 2. This is the graph of y equals negative 2. So if a y problem is horizontal, then hopefully you can keep in mind that an x problem is vertical. So again, if you don't remember, we can set up our points. But this is telling us no matter what we pick, x has to be -2. So I have to have a -2 there, -2 here, -2 here. Pick any values that I want for these other spots. And again, I like 0. We'll pick 2 here, and we'll pick -3 here. So when I graph those points, -2, 0, -2, 0 would be this point right here. -2, 2 would be right here. And -2, -3 would be right here. And if you connect those 3 blue dots together, you'll notice that you get a vertical line. So anytime you have an equation that's in the form of x equals, your answer is going to be vertical. So what if I had x equals 3? Then I'm going to go to the point 3 on my graph. Here's the point 3. And I'm going to have a vertical line going through 3. So this is the answer for x equals 3. If I had x equals -1, I'm going to go to -1 on the x-axis and draw my vertical line through -1. And so this red line that's here is x equals -1. So one of the measurements that we're going to talk about is what we call slope. And slope is talking about how steep a line is. And another important term that you're going to see is it's the rate of change of the rise and the run. So we're going to find the rise, which is the y values, how much is it going up or down, and then we're going to find the run, which is the x values, how much is it going across, and we're figuring out the rate of change, so we're figuring out the ratio. So it's important here that your x's and y's can't, your x1 and x2 can't be 0. If they are 0, if both of them are 0, or they're equal to each other, then you're going to end up with an undefined problem, and we're going to talk about that in a minute. So we're taking the change in y, so we're subtracting the y values, and we're subtracting the x values, and we're going to end up with a fraction, because we want the rate, we want the ratio, or the rate of change. So we want to leave the answer as a fraction, always. Okay, so let's go through an example. So here we have 2 points, 3, 5, and -2, 1. So if we do a quick sketch just to see where those 2 points are on our graph, so we have 3, 5 is up here, -2, 1 is over here, and we want to find the slope between those two lines. So to do that, again, remember our formula. This is x1, y1, x2, y2. Our formula is y2 minus y1 over x2 minus x1. So we can substitute our numbers in. 1 minus 5 over -2 minus 3. So we end up with -4 over -5. Remember I said simplified fraction. Negative divided by negative is a positive, so we get 4/5. Now one of the things I wanted to remind you, it doesn't matter whether you switch which one's x1 and which one's y1. So let's just say I made this x2, this one y2, this one x1, and this one y1. If I made that switch and plugged in my numbers, I would end up with 5 minus 1 over 3 minus -2. So if we work this out, we're going to get 4 over, because remember this becomes positive, 5. So we end up with the same slope, whether I have, no matter which way I label my x's and my y's. So just keep that in mind as you're working through these problems. Okay, so we already talked about this. For vertical lines, remember we talked about they're always going to be in the form of x equals something, where a is a real number. And for horizontal lines, it's always going to be in the form y equals something, where y equals b, where b is a real number. So let's look at that one more time. So if I have a vertical line, so here's my graph and here's my vertical line. If I have a vertical line, the slope of this line is undefined. The slope of this line is undefined. That means that when we look at rise over run, there is no run. Or another way of looking at it, the run is 0. So if I try to say rise over run, I'm going to be trying to say some number, it doesn't matter what, over 0. And you can't divide by 0. So the slope is undefined for a vertical line. Whereas with a horizontal line, here's our horizontal line. If we think about a horizontal line could be a street, it could be a road, it could be a walk, a sidewalk. So the slope of this is 0. Okay? In this case, the run is some number. In other words, you travel from one point to another, but the rise is 0. You did not go to get from this point on the graph to this point on the graph. You did not go up at all. So it's rise over run, and anytime you divide into 0, you end up with 0. All right, so here we want to graph the line graph the line that has a slope of 2 over 3 and passes through the point -1, +1. So remember, 2 is the rise, 3 is the run, and this is our starting point. So we're going to make our graph. We're going to go to our starting point. So -1, +1 is right here. And then from that point, we're going to go up 2, because the rise is 2, so we're going to go up 2, and we're going to run 3, so 1, 2, 3, so we're going to run 3, and there's a new point on our graph. And then I can connect those together, and there's my graph. Now technically I can do this process again, because remember that 2 over 3 is the same thing as -2 over -3, because the two negatives cancel out. So if I go down 2 to the left 3, you'll notice that I get another point that if I extended this line out, it would be on the line again. So you can continue this process on a graph as many times as you want to figure out a multiple number of points. Okay, so let's look at another example. This time our slope is -2 over 3, and it passes through the same point. So what they're telling you to do this time, is they want you to start at the point 1, -1, but this time we're going down 2, so we're going down 2, which is -2, we're going to the right 3, and we end up with a point over here on the left. So you'll notice that this line is going in a different direction than the first line that we drew on the other example. Okay? So what we're going to summarize here is that when we're looking at these lines, a negative slope is always a slope that falls to the right. It falls to the right. A positive slope always rises to the right. Okay, another way of looking at it. A line that looks like this is negative, and a line that looks like this is positive. Another way to help you remember that is if you look at the negative slope, if I wanted to, I could form the letter N out of that line, and N stands for negative. So that's something to keep in mind. A negative slope always falls to the right. A positive slope always rises to the right. So now we're talking about parallel lines and perpendicular lines. So parallel lines are two lines that do not intersect. So parallel lines, what we have learned is that they have two parallel lines that are not vertical have the same slope. Two parallel lines have the same slope, so that's the important element there. Perpendicular lines are lines that form 90-degree angles. So two lines that form 90-degree angles. So two perpendicular lines have slopes that are negative reciprocals. In other words, I can multiply the two numbers together and get -1. So if I have 2/3, then its negative reciprocal is -3/2. If I multiply those two numbers together, I get -1. So if I have 2, then the negative reciprocal is -1/2. And I could think of this as 2/1. If I have -4/3, then the negative reciprocal of that number is positive 3/4. So when you think about negative, think about the opposite sign. So if I have the slope of line 1, and the slope is 4/3, so the slope of line 1 is 4/3, the slope of the line parallel to line 1 is also 4/3. The slope of the line perpendicular to line 1 is -3/4. If I have another line that has a slope of -5/4, the line perpendicular to that line is 4/5. The line parallel to line 2 is -5/4. It would have the same slope. So if I look at this example and I compare, because line 1 and line 2 have the same slope, they must be parallel. Since line 3's slope is the negative reciprocal of those, line 3 has to be perpendicular to line 1 and line 2. So if you imagine this, line 1 could look like this, line 2 could look like this. Not a very good drawing. And line 3 is perpendicular to both of them. So here's line 3, and it's perpendicular to both of these lines. All right, so another way, again, of thinking about slope is to be called the rate of change. So rate of change, again, is the change in the y's over the changes in the x's. And a lot of times we'll use this concept with real-life examples to figure out how much something is changing. So here's an example. A computer that was worth $2,000 in the year 2004 is now only worth $800 in the year 2007. So they want to know the rate of change in the computers over this 3-year period of time. So imagine that you have ordered pairs. So 2004 is the year, and 2000 is the cost, and 2007 is the year, and $800 is the cost. So because they're written as ordered pairs, this is the x value, or x1. Well, if you'll notice the way that they did it, they called this one x2, this is y2, this is x1, this is y1. Remember how I told you could switch these around. So y2 minus y1 would be 2000 minus 800, and x2 minus x1 would be 2004 minus 2007. So 2000 minus 800 is 1200. 2004 minus 2007 is -3, and those two numbers divided give you -400. So that's telling you that the value dropped by about $400 per year. So if you think about this as being a line, this would be a line with a negative slope. So because it's a negative slope, the line would look something like this. And if we continued that pattern, there's always that possibility that computers could be free eventually, but that's not going to happen. So there is some boundary to that. All right, I hope this is helping you. Keep in touch. Let me know if you're having any problems. Have a great week, and I'll talk to you later.